Hello student, in this video I'm going to discuss about few more idea related to sound and or you can say audio, how we can sample the audio and the characteristics of sound or we can say audio. So here starting with sound wave characteristics. The amplitude of the sound is the volume or loudness a particular sound makes. That is well understandable. The amplitude and the amplitude is the volume or you can say loudness. Louder the sound, higher the amplitude will be. The unit of measure for loudness or volume is decibel. So here you can see in this picture, this is the amplitude of that wave, and this is the wavelength of the wave, and this is the time. This might be 1 second or 1 unit of second. Same, this is same wavelength, the lambda amplitude, same amplitude of that wave. Okay, so the amplitude is the volume of the sound. In a digital sound refers the reproduction and retransmission, or you can say reproduction and transmission of sound stored in digital format. In case of digital sound, we store the information in a digital format. The digitizing and storage of sound or music on a computer or you can say compact disc. The conversion is done by a digital audio signal starts with an analog to digital converter ADC that converts an analog signal to a digital signal. After being sampled with the ADC, first using the ADC or you can say analog to digital converter, the sound wave will be sampled. The digital signal may then be altered in a process which is called digital signal processing. The digital audio signal may then be stored for transmitted. The last state for digital audio is to be converted back to analog signal with a digital to analog converter. So opposite of analog to digital converter is digital to analog converter. So here you can see the diagram of the conversion. First, it might be a source of the input, source of the sound. It might be microphone or guitar, analog input. Analog to digital conversion, that is ADC, that is digital numerical data samples, or you can samples will be gone through a digital system. It might be computer, compact disc, any computer digital system. And if we want to revert back or if you want to transmit the sound in as analog form from the digital system, it will be converted to the analog output, that is a loudspeaker, using a digital to analog conversion. So actually here in the red part, electrical voltage variations might occur. So in case of sampling process, in order for a computer to work with audio waves, they must be converted from analog to digital form. This is done through a process called sampling. So in order for a computer to work with audio waves, they must be converted from analog to digital form. So this is done through a process called sampling, in which every fraction of a second a sample of the audio is recorded in digital bits. So every fraction of a second a sample of the audio is recorded in digital bits. There are two factors that affect the quality of the digitized audio: sample rate and sample size. Sample rate is the number of times the sample is taken. So directly understand this, that sample rate is the number of times the sample is taken. The three most common sample rates are 11.025 kilohertz, means 11,025 hertz, or per second, 11,025 per second samples has been created per second, or 22,050 per second sample has been created. Like that, the higher the sample rate, the more samples that are taken, and thus the better the quality of the digital audio. Here you can see lower sample rates take fewer snapshots of the waveform. Faster sample rates take more snapshots, resulting in a rough recreation of the waveform, but resulting in smoother in case of higher sample rate and more detailed recreation of the waveform. Again, sample size is amount of information stored about the sample. The two most common sample size are 8-bit and 16-bit. So that is about sample size. It means how the amount of information is going to be stored using 8-bit size or using 16-bit size. If you use 8-bit sample, then it will allow 26 to 256 values that are used to be described audio, whereas in 16-bit sample provides 65,536 values. The greater the sample sound size, the better the quality of the audio. So if you use sample rate 44.1 kHz using 16-bit value, the size of the file will be 1.76 MB. But if you use 44.1 kHz sample rate using 8-bit value, then size will be decreased. Table below shows the file size for 10 seconds of digital audio given various sample rates and bit values. For in 10 seconds, it will create that much amount of data for different type of sample rate and bit value. Again, in case of sound, there are two types of sound can be there, channel can be there, that is monophonic or stereophonic. In case of monophonic, commonly called mono sound or mono or non-stereo sound, this early sound system used a single channel of audio for sound input. Monophonic sound is most basic format of sound output. Mono or monophonic or monaural is sound from a single source. All speakers in a mono system will carry the same signal like a intercom. Here you can see one snapshot of a monophonic sound wave. In case of stereophonic, commonly called stereo sound or just stereo, stereophonic sound divides sound across two channels recorded on two separate sources. Then the recorded sounds are mixed so that some elements are channeled to the left and others to the right. Stereo is sound from two sources, ideally spaced apart, and reproduces sound the way we hear it naturally with two ears. Like here you can see, in case of stereophonic sound, this type of one sample you can see here in this picture. Two different types of waveform has been included in one sample. So you can understand two different source of information or source of sound is there in this wave. Again, in case of storing the sound data, we can there are two means of storing the sound data: using waveform audio or digital audio, or using musical instrument digital interface. There are different types of file formats available for storing the sound. We have already discussed few of them previously, and again we have discussed this part: sound file size, how we can calculate the sound file, sample rate and sample size into channel into duration. So if it is monophonic, then channel will be always 1, but in case of stereo will be 2. Duration is the time that for what time you are taking the sound, and the sample rate, number of sample size, 8-bit or 16-bit. So suppose we need to calculate how much storage space is needed to record a 16-bit 44 kHz stereo music for a duration of 13 seconds. It will multiply 44 kHz or 44,100 into 2. 2 is for 2 byte. 2 is for 2 byte. 2 byte means 16-bit, and then this is 2 for stereo music, and this is 30 seconds. Then you will create 5 to 9 to 1000 bytes of size. And again, if you want to calculate how much storage space is needed to record a 8-bit 11 kHz mono sound for a duration 10 seconds, 11,000, that is sample rate with 1 byte. 1 byte means 8-bit into one channel is for mono, and 10 seconds is the duration. Then it will create 1,10,000 bytes. A guideline is that consider the appropriateness of using sound. Start with highest quality sound variable available and reduces file size by converting the audio file to a compressed format. Consider using sound and still images as an alternative to video to reduce the file sizes. If appropriate, provide a way to give the user some control over the audio. So next is about video. So video is the technology of electronically capturing, recording, processing, storing, transmitting and reconstructing a sequence of still images representing the scenes in emotions. Video makes use of all of the elements of multimedia, bringing your product service alive but at a high cost. What is the high cost? That is about the size of the video file. The advantage of integrating video into a multimedia presentation is the capacity to effectively convey a great deal of information in the least amount of time. Video is also very hardware intensive, require the highest performance demand on your computer. So to produce a video or to display a video, the computer provides highest amount of performance or requires highest performance that is demanded for any computer. Storage issues also there, like for full screen uncompressed video uses over 20 megabytes per second of bandwidth and storage space. Processor capability in handling every huge data is also another factor to consider, because your processor need to has the capability to handle very huge data on real-time delivery. Digitizing the video signal, again in case of like the audio signal also we can digitize the video signal. In case of analog, video is essentially a product of the television industry and therefore conforms to television standards, but in case of digital video is a product of the computing industry and therefore conforms to digital data standards. Now how we can digitize the video signal? Is usually recorded and played as an analog signal. It must therefore be digitized in order to be incorporated into a multimedia title. Here you can see, though the figure is not much visible, but I will go through it. First one is source of video signal. It might be VCR, camera, TV or video disc. That is the source, or that can be a storage house, and it will send the analog signal to the system. Then computer will convert that on a video signal, analog signal. Video capture card converts signal from analog to digital format, and it will store this video file on the hard drive. So advantages of digital video is that, one of the advantages of digital video is that it can be easily edited. The video is stored as a standard computer file. Software motion video does not require specialized hardware for playback. Digital video requires neither a video board in the computer or nor an external device, which adds extra cost and complexity such as video disc player. But advantage of digital video is more about long lasting. Disadvantages of digital video is that it requires large storage capacity devices. Copies can be made illegally. Need first computer system for playback and capture. Requires knowledge of digital compression technology. Now how we can measure the file size of the digital video? Digitized video files can be extremely large. A single second of high quality colored video that takes up 1/4 of a computer screen can be as large as 1 MB. Several elements determine the file size. It might be the frame rate, it might be the image size, it might be the color depth, it might be the length of the video. All of these elements will determine the file of the size. Again, in case of video, we can apply the video compression techniques. Because of the large size associated with the video files, video compression or decompression programs are known as codecs have been developed. These programs can substantially reduce the size of video files, which means that more video can fit on a single CD and that the speed of transporting video from a CD to the computer can be increased. So there are different type of digital video file formats are available. We have discussed few of them in the first class of the multimedia, first or second class of multimedia video. Now how can we calculate the video file size? So here to calculate the video file size, we need to multiply frame size into frame rate into color depth into duration. So in case of color depth, black and white video has 1 byte, or we can say 8 bit, but in case of colored video it has 3 bytes, or we can say 24 bit, because it will use RGB color. So for 3 color, it is going to use 3 bytes of information. 3 bytes means 24 bit, 8 bit for each color. So in the example 1, we can see is that suppose we need to calculate the size of a video with 320 into 240 pixel per frame and 30 frame per second, and length of the video is 15 seconds, and this is a colored video. So 320 into 240 is the image size, okay, and this is 3 byte for color image or color depth is used, and the 30 is the frame per second. That much of frame will be passed per second into 15 seconds. Then it will create this much amounts of bytes of data for that same video. In case of black and white picture having 300 200 pixels, 225 frame per seconds for 30 seconds, 300 200 is the image size, 1 byte is for black and white color depth, 25 is the frame per second, 30 is the duration, then it will create that much amount of data. So how can we reduce? The guidelines is that reducing the color depth to less than 256 colors gives a markedly poorer quality quality image. So if you reduce the 256 levels of colors to reduce the color depth, it will provide a poorer quality image. So it is better to not reduce the color level. In most multimedia titles, you do not need to show full screen video. Obviously you can avoid the highest use of data by reducing the full screen video. Reducing the file size to minimize the use of video in the image that appears on the screen. So reducing the file size to minimize the use of video in the image that appears on the screen. So reducing the file size, obviously it will minimize the image that will appear in the screen. So these are the important information regarding sound and audio. In the next class we are going to learn, in the next video we are going to learn about digital compression technique. So till then, if you have any doubt or confusion or anything to add, please let me know. We'll try to resolve the thing over Google Meet. Thank you.